Well, now, let's have more on the discovery of the strongest evidence yet for the existence of the so-called Higgs boson, the subatomic particle that is thought to give other particles substance or mass. The announcement was made by researchers at their centre near Geneva this morning. And the best person to explain it to us is in the studio with me, because it's the physicist and broadcaster, Professor Brian Cox. Brian, great to have you with us. Thank you very much. Well, it's very rare to be reporting news in such superlative terms and very, very strong statements and claims being made. Why don't you just tell us, in your own words, what you think has been achieved here?
Well, I think this is the biggest scientific discovery in my lifetime, and it stands with the great scientific discoveries of all time, discoveries like the discovery of the electron, the discovery of atoms. And the reason is that this is genuinely fundamental. I mean, the theory says, and it's been around since the 1960s, by the way, this theory, that the universe is full of Higgs particles. So that means here, that piece of space in front of me now, and indeed inside me, and in every piece of space out to the edge of the universe, is crammed full of these Higgs particles. And the things that make up you and me and our bodies and everything we can see are bumping into them, and in that process they acquire mass, which means they're solid, which ultimately means that we exist. So it's absolutely genuinely fundamental. It's a very beautifully simple theory, although it sounds very odd, but I think that the act of building this thing, the Large Hadron Collider, the most complex machine ever built, to go and test this theory and then to find that it's actually true, it's actually genuinely right, I think is quite remarkable.
How did they make the discovery? It's a very simple question, but how did they... it's been a 45-year search, I mentioned that earlier on. What precisely did they discover that made them say, that's it?
Well, we made them, and the reason, by the way, it's taken almost half a century is because they're very heavy. The number is 126 times the mass of the proton, which is extremely heavy. So you need a lot of energy to actually make real Higgs particles. Although empty space is full of them, you've got to make them in an experiment to see them. So we made them in these collisions, and we saw them fall to bits, we reconstructed them, and there's a handful, there are several hundred of them have been seen now, so that makes it significant enough to claim a discovery. And that's what's been claimed today.
So how will this knowledge be applied? How is it going to help understanding about the universe and how the world works? How will we see practical representations of it?
Yeah, I mean, the first thing to say is it's deeply fundamental, as I hope I've said. It really is about as fundamental as it gets. The answer to the question, what is this going to lead to, if you're talking about technologies, the answer is genuinely we don't know. But what I would say is that finding out fundamental things about the way that nature works, remember, we're part of nature, finding out those things has been, in the past, the road to civilization. It's not too hyperbolic to say that. Obviously, the discovery of electricity, the discovery of the electron, the discovery of the atom, quantum theory, which led to transistors. This road is, genuinely paved with gold. And this is one of the most fundamental things that's ever been discovered. So I couldn't guess, but I bet you in 100 years' time we'll look back at this week and say that was one of the most important moments in the history of science.
Brian, it's great to talk to you, and thank you very much for coming in and putting it in such clear terms for us. Thanks very much. Brian Cox, then.